right, left, right, down, up. So it's working. So you can't see that I'm pressing keys, but you see that the tank is moving, not just to the right. So I am pressing keys and it's working. The one thing we don't have here is rotating it. So now that you've seen, quite a bit of this ECS system, you can probably guess what you should do, and that is adding. Welcome back to Arcade. I am Super Tommy, and this is part 2 of using bitECS, that's Entity Component System, with Phaser 3. Now, be sure to check out part 1, where we set up using bitECS in a Phaser 3 scene. Do not just come in here in the middle of part 2, things will be confusing, so do check out part 1 to see how we set up this Entity Component System library, bitECS, which is going to be, or at least currently, used in Phaser 4. So do check out part 1. And while you're there, be sure to hit like and subscribe to Arcade for more videos on using Phaser 3 with various game patterns, including Entity Component System, the Entity Component Pattern, state machines, and much, much more. If you do like this content, subscribing and hitting like is the best way to support this channel. So now let's continue here on here with using bitECS in Phaser 3. So let's go smaller for me. So what we have here left off with in part 1 is we have this sprite system that is going to render our tank, and we have our position component that we've added on our tank entity, a velocity component, and the sprite component. That's how we are rendering this sprite, this tank sprite right here. So do check out part 1. Now let's real quick, I'm going to do some cleanup in this code. We've got all our components and all our systems in this scene class, this main game scene file. So let's go to our folder structure. I've got a components folder, and I'm just going to make some files in here. Let's call this position.ts. And we're going to make another folder, but let's just copy some of this position. So we're going to take this, let's just take all of this for now here. So we don't need these. And then we're going to export our position. Right, so now we have our position component in a separate file. We can go over here, do import from components position. Right, so that's how we can organize our components. I'm going to just do one for this video. You basically get the point. I may do another one if I need to move some more files into a specific, some more components into a specific file. Let's look at this system. We're going to clean this up. So this system, of course, is a lot more complicated. It's got query, enter query, exit query, and a map to hold all the game objects that we're actually going to make. Now, to make that a little cleaner, system, let's go to our systems folder. We're going to make a new file. Let's call it, we can call it sprite system. Okay, let's go back to our game. We're going to take all of this. So that thing, let's just copy that in here. Okay, and let's go to game. Just take these imports. Let's go over here. All right, so we don't need these. Don't need these. So we will want to import our position component here. Components, position, and we're going to need our sprite component in its own file. So let's come over here, sprite.ts. Let's go to game. Gonna need that. And we're going to have to import from bitECS types and define component. Now let's export that. Go back to our sprite system, import from components sprite. Now all those errors are gone. Fantastic. Fantastic. Now let's go back to our game and just make sure we're not double making components here. Import from components sprite. And that. So it's there. This should still work. Alright. Alright, so now our code is a little bit more organized. You can, of course, further organize this with this velocity component, which we probably have to do anyway. What we're going to do in this video, we're going to do a movement system. So we are going to need to do this anyway, so let's just take that. Let's come up here, velocity.ts, and we want basically the same import from bitECS. For that, we want to export. Got that. Let's go over here. Let's just import our velocity component. Velocity. All right. So we already, we don't need this system since we have moved it. So let's delete that from here. But we're not done with that system change yet. So we'll leave that error so that we know. So let's go back to our sprite system here. Now we're gonna take a deeper look into this. So we're gonna export this function, of course. So this is a function that returns the result of another function, namely this define system from bitECS. Now what we can do if we were creating, let's just say, multiple sprite systems for whatever reason, we don't necessarily need to share all these queries or like maps. Let's just put all this stuff inside here. So for each time that you're making a new system, we're just going to create the query, the normal query, the enter query, the exit query, and make this sprites by ID map. Now the code doesn't really change. We simply moved it out of the more global module scope into the more local function scope of our create sprite system function. That's it. This is a little bit cleaner, so you know that anything within here is being used by this system here. That's all. Now let's go to game. We're going to import this system. So systems, sprite system, and we want to do create sprite system. Oh, good. All right. Our demo is still working. So now we want to do a movement system that's going to handle moving our tank. So we're going to move based on velocity. So our velocity here is, well, this is not tick. Well, I guess this is fine. We'll just call this, yeah, velocity is fine. So our velocity right now is, for this tank, is 5.5, which would be this way. But let's just say our tank can only move in north-south and east-west directions. So in this case, we just move right. So we give our tank 0y velocity. Now we have no system currently to handle that. Let's make a new system. We're going to call it the movement system. Come to our systems here. We'll call a new one. Let's call it movement system.ts. Let's go import from bitECS. We are going to need define system. Just check some notes here. So we're going to need our position component. Position. We're also going to need our velocity component. So because what we're looking for in movement is something that has a position and that can be moved, hence velocity, as a change in position. Velocity. So let's do a export. We can do export default function, create movement system. So if we do a function that calls define system from bitECS, it's a little bit nicer. We can pass whatever we want in here that we may need. For the movement system, we don't need anything, but as you saw from the sprite system, we did need the scene and a list of texture strings. So we have that. So now we're going to do return define system, which takes a world. It's just a function that takes a world. It also has to return a world. All right. Now in our movement system, we need a query. Define system, create, define query. And our query, let's go over here, let's just call this define query an array. So any entity or all entities that have a position and velocity component attached to them is going to be in our query. And just like before, we're going to call these entities, run the query with world. Now we're going to loop through all of these entities. Now this is going to be the ID is each entry in this array is the ID of the entity, and we're going to just adjust their position with their velocity. So we do position.x ID plus equals, so we're adding velocity to position, velocity.x ID, and we're going to do this also to y. Return world, and that should be it for the movement system. So once we create the system in our game scene and set it to run in the update loop, our tank should just move to the right. So let's see what it does. So sprite system, private movement system. So this dot movement system, we want to do create movement system. So now that we've moved a whole bunch of stuff around, we don't need these anymore. So import from systems movement system. Create. Is that right? Let me just double check movement system. Oh no, that's a default export. Let me just not export default. I'm just going to export. There we go. Cool. There. Okay. So create movement system. That's it. So now, when we're in update, we want to update in the order that is appropriate. So sprite system should run last. That's like the rendering step in this example, since we're using phasor-driven rendering. So we want to do this dot movement system, this dot world. Now if I am correct and do this, this is just the TypeScript shorthand for only invoke this function if it exists. So we can, make this a little bit, I don't know, prettier. If you don't like the syntax, then it looks terrible, but just so that we have less things to check up top. So we're going to do the movement system, then we're going to do the sprite system. So let's see if what I did is correct. Save, and our tank is moving. It's going to move that way forever. So that's, the movement is working because we added this velocity and position to our tank. Now if we simply don't do this, then the tank will no longer move because it does not have a velocity component and it will not be affected by that system. So that's how this entity component system concept works. You have entities, they're added components, and in the systems, if they match a specific query, depending on what components they have attached to them, logic is applied to those entities only by that system. And so you have this nice separation of state and logic. So we have that. So now let's actually do some input. We're going to do a input component, or let's just call it the player component, since this is with player input only. Let's just add our velocity thing back here. We'll just let our tank roll off screen. Let's make another system. Let's come here. We'll call it the player system. You can call it input system or whatnot. Okay. Import. Let's say we do define system from bitECS. Define system. So export function create player system. And then we're going to return a define system. We're going to pass that into our system. It returns a world. So, okay, so what is our player system going to need? It's going to need to take in cursor input. So let's just take that in here, cursors, and it's going to be a phasor cursor. cursor, so phasor from phasor. Phasor.type.input.keyboard.cursor keys. So we're going to take cursor keys, and based on the information from cursor keys, we're going to decide what to do here. So let me just double check. Okay, so in our case here, we need a player, so we need to only operate on anything with a player component so that we can know that it's a player. So we can just make a component player, do a query here. We need velocity since we're changing that depending on the arrow keys that we're pressing. So let's make a player component. Player.ts. And we're going to want these. So a lot of these components are very similar. They don't even have to be in its own class, own file. They can all be in one file since they're just state. There's no logic in it. But anyway, export const player define component. And so let's see. I don't think we actually need anything on this component. So if you want to make yours like a tag, if you want to use it as a tag, you can just do this. Now in the future, if you have multiple players, right, you can of course give it an actual property or state, like, you know, player index, player number, or whatever it is, and that way you know, given that player component, like maybe which input they should respond to. But we're going to keep it one player. So that's our player component. This is just an empty component used as a tag. So let's go to our game, and we are going to need to add this component to our tank player. And let's see, let's just add it last. Add component this.world player tank. All right, nothing will really change logically because we don't have a player system yet. So here we want to define a query. Here's const query. Let's define query as player. So import from components player and velocity. You can only control something that can actually move. Velocity. So player velocity. And just do, just like in all the other systems that we have query, we execute the query to get the entities for that frame that still apply. And then we just loop through all those entities length and operate on them in one pass per system. So for input, we're going to have to check that our cursor, buttons are that down, or rather left is down, up is down, right is down, and down is down. So if you've seen our other videos, check. You've seen our other videos on doing movement in phasor. We're going to keep it basically like that, except you can see this is why this is a it's sort of inverted, where in the normal phasor thing you may have a player class. In that player class it has an update, and then in that update it does a thing. If you have multiple things you control, you would have a bunch of players, and then they each have an update, and then you do the logic in each one. Here's kind of inverted. We're going to loop through all those players and do all the thing inside this for loop versus having to drill down into the update for each object there. So, but conceptually it's still very similar logically. So we're going to do if cursors dot left dot is down. This means we're moving down. So we're going to do position. Actually, we're going to do velocity dot x for this entity, so going left, let's just say -5. Velocity dot y. Don't need this. So you could make 5 a constant just for simplicity here. We're just going to go with this. Dot right dot is down. And so right is what we're starting with here. That. Else if cursors dot up dot is down. In that case, it's that, and then it's -5 up. Else if cursors dot down is down. Yep. Velocity is the opposite, so that's that. 5. And lastly, if there is none of these are pressed, it's not left is not pressed, right is not pressed, up is not pressed, down is not pressed, we are not going to move at all. So we'll actually stop. Okay, so that is our player system. Let's go back to game. Private player system, which is a system. Let's make our player system. This dot player system. Create player system. So it was auto imported. This dot cursors. Oh, I didn't make a cursors yet. Private cursors. Let's just say that's definitely going to exist. Phaser.types.input.keyboard.cursor keys, and that's going to do this in init. This is the init hook of a phaser scene. This dot input dot keyboard dot create cursor keys. Got that. Player system. And let's start our tank with nothing, which is going to be 0, 0 XY velocity. And so we have a player system. Now we need to update our player system. So the order here is usually important, and it really depends on your specific systems which order they should run in, and the game you're actually making. Now in our case, let me see, we should do our player input first. That's usually always the case in any game loop. Take in input, and then a bunch of other things happen because of player input. Okay, so if I say right, left, right, down, up, so it's working. So you can't see that I'm pressing keys, but you see that the tank is moving not just to the right. So I am pressing keys and it's working. The one thing we don't have here is rotating it. So now that you've seen quite a bit of this ECS system, you can probably guess what you should do, and that is adding another component. Now we're going to do a rotation component for simplicity here. So let's just do that. Let's call it rotation.ts. It's going to import define component and types. I could have done this first from bitECS. So export const rotation define component. We're going to have, let's call it angle. That's going to be in human readable angles, which is types dot, I think uint, well, we may want to use negative numbers. Just go with I8. No, that's not enough. I16. All right. You can, I mean, of course, if you're just starting and you don't really care about saving space in memory, you can just do I64, or is it I32 was the max we have in JavaScript. I32. Okay. I32 being the biggest number we have, you can just go with I32. Oh no, this is an angle, so it's not an int. Float. Let's go float 32. Okay, here's our angle, float 32. But we're actually only going to use whole numbers. We're going to just do 0, 90, 180, 270, and back to 0. But let's just use it as float 32. Okay, that's the component. Great, let's go to our game. Let's import our rotation component. Rotation. And here, velocity position, let's just add it this.world rotation, give it to our tank. Great. Now in our player system, we can just set the value of this rotation component, or the values for the tank for the rotation component. Rotation. And we want to make sure that we add that there, so that when you press, so that you would only operate on entities that have these three. Now, if you didn't want to have rotation be for guaranteed to exist here, you can make another system that then only listens for maybe player and rotation, or some other way you want to set this up. If you want it to be more lenient, because in this way it will only give you the entities that have all three of these components attached to them. In our case, it's fine, and in most cases it will be fine, but that's just something to note, that this is an and operation. It's not or, it's when they have all three. Okay, rotation dot angle ID. Okay, left. So this is 0, left is 270, I think. Let me just double check. Oh, no, not 180. Math. Okay, so right is 0, down is 90. Yep, and this is 270. Now, we also need to make sure it gets rendered, and our renderer is the sprite system. So let's open up that sprite system. And here we also need to take that rotation, okay, and go here. So sprite.angle is going to be rotation.angle ID. So we can just set the rotation value to the sprite, the phaser sprite, so it could be rendered, angle value on that sprite. So now I'm going right, going left, right, up. Oh, I reversed something. Let's go back to our player system. I'll just double check here. Up. Okay, up is 270. Down is 90. Okay, there we go. All right, so we've used ECS here. This is bitECS with Phaser 3. We've implemented the basic stuff in part 1 where we just got this tank to show up. Now in part 2, we've got input, keyboard input to move a character tank around. So we're making good headway here as an introduction to NAD component systems with Phaser 3, specifically the bitECS system currently being developed with, currently being used in the development of Phaser 4. So if you enjoyed this video, do hit like and subscribe for more videos on using Phaser 3 and bitECS. In fact, our next part is going to be where we add a whole bunch of AI tanks. They're going to move on its own using this ECS system. So do hit like, do subscribe, and come back for part 3.